All right, so part B. Let's see. Okay, so for part B, it says determine the speed of the small block after the collision. By the way, I'm going to scratch out part 1. Well, see how last time we were kind of looking at one object kind of in the system. Now we're looking at 2 objects, and you see the word collision. Usually anytime you see the word collision, what that's going to mean is you're going to use conservation of momentum. And I'm going to write isolated system again, because no outside force on system. You don't have to write that again. You can just draw a line from where you wrote it in the first one. And so I'm going to put therefore P equals P prime. Whoops, momentum before equals momentum after. And if you recall, MVP, most valuable player, is momentum, and this is velocity, so be careful. And I'm also going to say this is a positive direction, this is the negative, although I think everything travels in the positive direction. So anyway, let's look at this. So the momentum for the system before, well, you've only got one block moving. It's little m, and it's moving at 3.5 v naught. So let's go ahead and just plug everything in. And then this one is, since the velocity is 0 of the larger block before the collision, there's no momentum. There's no need to even include it. So the mass is just m. We're going to multiply that times 3.5 v naught. I'll put these in parentheses. All right. And what you're going to end up with afterwards, they're both probably going to be moving, since they want you to find the speed of it afterwards. Think of it as like you slid down the slide to kick your brother or sister, you know, send them flying, and you kind of finish sliding down the slide. You're like the smaller mass here. So let's look at that. So we're going to have the momentum for the first block afterwards is going to be m, and then let's just put v prime. That's going to be what you're searching for, is v prime. You can name that v whatever you want. I just put a prime. And then we're going to say plus, because they're both going in the same direction. They're both going in the positive direction. So we're going to say plus 1.5 m, because that's the bigger mass. It's 1.5 times bigger than the other, more massive than the other one. And then remember they said the velocity after was 2 v naught. So we'll multiply that by 2 v naught. Okay. So this looks good. And in this case, because these numbers are weird, I use parentheses, however you want to do that. You don't have to you can just move that to the front, however you want to do the math. So let me just kind of clean this up. You're going to have 3.5 v naught. This step I'm doing right now, you don't have to do. mv prime plus 2, that would be 3 mv naught. So what I would do here is subtract this. Oops, I forgot my m up here. Oops, okay, so I'm going to go over here. Therefore, mv prime equals, well, 3 minus 3.5, I think that is 0.5 mv naught. And then I'm going to divide by the m's cancel out. And so v prime should be 0.5 v naught. I think that's it. Let's score this. Okay, so it looks like I got the right answer, but did I do the right work? So anyway, this says for any use of conservation of momentum. And again, the isolated system on the new AP test, you have to include that too. Plus 1, so yes. Okay, for correct expression of the initial momentum of the blocks. See this? That's correct. Plus 1. Okay, expression of the blocks afterwards. Yep, looks like I got that. This is afterwards. It just says what, see how this is like saying expression, like you're telling what's happening? That's what happens. That's because they want you to say the right thing with physics. I guess that's the best way to put it. And then 1 point for the right answer. See how little the actual right answer is worth? So you got 4 points there. So that should be good on that.